Hello again and welcome to the IoT Insider podcast. Willem, so we have published 30 episodes until now.
Okay, already?
Yes, 30, already 30.
Okay.
And we did not talk about IoT yet.
How did we manage to have 30 episodes without mentioning IoT?
All right, so welcome to episode 31 about, drumroll, obviously IoT. And we're joined by Olivier Bloch and Ryan Kershaw. Gentlemen, welcome.
Thanks for having us.
Yeah, thanks.
Hey guys, so you both have super interesting backgrounds. Let's, Olivier, why don't we start with yours? Maybe a quick introduction in who you are and what you're doing.
Definitely. So Olivier Bloch, I'm a partner director at Thing Zero, among other things, looking into OT, IoT, and all things fun. That's to rewind my career and give you some more context. Fun and IoT has been part of my DNA and job forever. Started 27 years ago as a developer for real-time system, telematics, and robotics and things like that. And I happen to specialize in Microsoft embedded technologies, so Windows CE, RIP, and other fun technologies like that. And that got me hired by Microsoft, spent 17 years with a big company doing Windows embedded, doing open source, and doing Azure IoT. I spent 7 years with the Azure IoT product team, looking after all the developer experience, all the device SDKs and fun stuff like that, trying to educate Microsoft people on how you do embedded and what an embedded device is. I was kind of successful. I'm pretty happy with that. And it's been a couple of years now that I'm involved in different endeavors, advising companies on IoT, and I'm more involved with Thing Zero, helping our customers understand the IoT realm and how it fits into that OT and IT integration that we all think about and care about.
And you have a super interesting YouTube channel as well on IoT,
Absolutely.
which I highly recommend our listeners to take a look.
Definitely.
I'm pretty sure our listeners probably know it already.
Yeah.
Maybe. You never know. So the
Maybe.
interesting thing, we'll talk about that. The interesting thing is that, you've not talked about IoT, but you have. Because in all your talks, there were components that were related to connected devices, security at the edge and cloud, and things like that. But we'll talk.
No,
about
absolutely. But nevertheless, it's good to have this dedicated IoT episode here. Hey, and Ryan. So I obviously. We talked before this meeting. I looked at your LinkedIn profile, and then I saw this with this sentence, which actually made me laugh. You said that you're equally comfortable with PNLs and PNIDs. So what's your story?
Yeah, so much like Olivier, partner and director over at Thing Zero. Unlike Olivier, do not have my own YouTube channel, but hey, who knows? Maybe one of these days. I kind of started the exact opposite of Olivier. So I started on the shop floors, instrumentation, controls, spent my days wiring things up and figuring out applications on, kind of how to take the physical data and transform it into digital. And then started moving up in the world, so to speak. Went into sort of the enterprise and the connectivity side of things. Started learning about this IoT thing. Like I'd always, people started talking about it. I was like, well, we've always been transmitting data. Like this is nothing new. Like it's always gone up. But the more you dive into it, it's like, wow, this is completely different. So ended up at a company that you guys might know. Well, you had him on the show a little while ago, Litmus. So I was there for a little bit. And, prior to that was running the business for a sensor company here in Canada. So that's where I get my P&L side of things. And then the PNID side of things, that comes from the sensors and controls and having to pour through those sheets and connect them, move one to beside the other and figure out where one line goes from one sheet to the other. And then, moved over to Thing Zero a little while ago, haven't looked back. Do a lot of work in the industry and associations. So I did some work with the Canadian Process Control Association, was there for a little bit, but have spent, and like Olivier, I was tallying this up the other day, coming up on 25 years, I guess, with maybe a little bit of a gap over at the International Society of Automation. So done a lot of work with that, and started with Toronto and moved up through and working with their operations and management technical advisory committee, which is a new way they're trying to do technical information, passing technical information back and forth. They got rid of the divisions. They felt it was a little too stringent. So, hey, we're trying this out and we'll see how it goes.
Okay. Olivier, I think for an introduction to IoT, you would be the perfect person. I mean, you started 27 years ago, basically, in that space. Could you give like a sort of a helicopter view of what happened in those 27 years? Because, I mean, that's even before David and I started working. So how did we get to where we are today?
They're making us feel old, Olivier. Jeez.
Sorry.
Definitely. So let me rewind and tell you about the history of
Come
IoT.
here, children.
Ouch. So that's really interesting. Everyone has their own definition, and depending on when you started your career, you have different approach to IoT. So IoT to me, my own definition has been for a long time anything that has compute and is not a server or a computer, right? So that's something that's very very broad, I would say, but that's on purpose because IoT is really about the things that surround us that have electronics and software that can or cannot be connected. Depends. IoT doesn't have always to be connected or not continuously, but that sometimes contribute through connection to a broader system in terms of sharing their data, receiving commands, right? And so when we talk about IoT, we talk about the technologies that power these infrastructure. And we started like a long time ago, with infrastructure at the edge. The first days of maybe Industry 4.0, maybe 3 actually, with automation, where we started bringing intelligence on these machines that started being able to implement some of their own safety limits, for example, thanks to some sensors and some actuators. And we went from these smart devices, right? Devices were starting to be smart, to connected devices, to machine, allowing them to communicate with one another, establishing protocols in between these different machines and equipments. Then we added the cloud component that allowed to remotely monitor and control these equipments and assets. And then we added, even more on the cloud side with fleet management and the ability to deploy software over the air onto these devices. And this is where we're at today. So pretty broad definition, I would say, but from my perspective, that's the way I would describe that to my grandma, who's still around and kicking and understands, a little bit about IoT.
Okay, so this is interesting because, and we'll do some more digging in IoT and IT versus OT, but we're sitting here with the I would say we're actually sitting with a real life demilitarized zone here, or more or less, because Olivier from the IT side, Ryan from the OT side. So Ryan, maybe how did you guys met? How did you break the IT OT silo?
Yeah, I mean that's interesting. Again, we got involved in Thing Zero and started working there, and I think at that point, yeah, you start to compare notes about how things are done, and it starts to make a little bit more sense. Coming from the top down and seeing what Olivier does and how things get put together on the enterprise level. I mean, that's always been interesting. The amount of data that you have to deal with on there, and a lot of the IT topics that really on the OT side you haven't dealt with before. But from the OT perspective, it's always been interesting over the past couple of years. I say couple, it's like 20 years now. But you look at the amount of data coming out of the OT side. When I was starting out way back when, because we're comparing to you guys right now. When I started out, like you get a sensor, and it put out a primary value. So let's talk like pH. So pH sensor would put out a pH value, and that would be it. Fast forward, and now you've got a pH sensor, even a small sensor, and it puts out a dozen different values. It puts out pH, temperature, it puts out glass resistance, it puts out time of life, time to calibration. And all of a sudden you're getting all this new information coming out. Now the question is like, how do you take that information and make it useful? And this is where, Olivier and I coming together makes a lot of sense. So now I can pass up that information. It's now up to Olivier to figure out, okay, how do I take this information, really make it useful? Like, can I take The time to calibration and port it over to the CMMS system, the computerized maintenance management system, to then, have people go out and maintain equipment as needed, not just on a scheduled basis, which it works, but that's the old way of doing things. It's not the efficient way of doing things.
It,
And if I may,
yeah.
if I may add to Ryan's answer, I think the divide or the cliff that or the gap that separates OT and IT is not at the people level. To me, it's more at two different levels. There's the data level that Ryan kind of touched on, where you have different types of data, different types of information, different types of formats that the IT world likes to deal with, and that the OT world likes or can deal with. And then the other one is infrastructure, where you need to have some compute, you need to have some communication, and that infrastructure that will span across the IT world and the OT world is where there's a lot of debate and contention, because we don't know what needs to be open and connected. We don't know what needs to be accessed and so on. And the tools that each side are using are very different. We're coming from the IT world, where we have basically, TCP and HTTP on top of that, and all the encryption layers and everything that comes on top, and then with every types of protocol. And then on the OT side of things, sometimes you don't have a wire, sometimes you have a very lean protocol, sometimes you have protocols that are not even encrypted because you didn't need to, because it was like between two machines in the same room that no one cared about anyways. And so this divide to me is not really much at the people level. OT operators need to understand, they know they need to understand IT and work with IT, and vice versa. It's just they don't speak the same language most of the time.
I thought we were fully standardized now on OPC.
Yeah.
MQTT everywhere. Yeah.
I was also going to say, I mean, there's the divide, there's not a divide on the people, but prioritization between IT and OT. Cybersecurity is a huge example, like a great example of this. There's the CIA model within cybersecurity: confidentiality, integrity, availability. And, if you're talking to an IT guy, hey, that's the priority, that's the levels they're going to give them priority on there. You talk to an OT guy and they're going to flip that on its head. They're going to want availability first, integrity second, confidentiality third, and safety's got to be up there along with availability. Like, they're not as concerned with confidentiality. The old OT side of things was like, hey, if I put a wire between these two devices, it's solid. Like, nothing's ever going to happen. And when we get into some of the IT tools, like, they're trying to bring this stuff down, but that's a big problem when we get to the OT side. Is there's not that expertise when we get down to the field level. There's still a lot of people that love those 4 to 20 milliamp devices because a new electrical grad can go out with the multimeter and triage it. It's you're not trying to bring in networking guys to handle everything down there. The networking guys have all been picked up by IT anyway. So there's this weird little dichotomy of priorities between the two sides, which is kind of interesting.
This touched upon something we've been also writing about, is the difference between, so people always say IT-OT convergence, but we split that into technology convergence or infrastructure convergence and data convergence. And one of the things, say no if you don't like it, but one of the things we tend to say is that from, I would say, technology convergence, this happened way sooner, already years ago, where we started interconnecting IT and OT, where we started using IT protocols or IT servers, etc., in OT as well. And now we are more in the data AI world. We'll touch upon that later. But I wanna go back to the infrastructure convergence thing. Is what made, I would say, IoT work? Because obviously we in the beginning we struggled with connectivity, and we struggled with security, and this cloud thing was then like all operators went like, yeah, no. So we've passed through several gates. What are the things which made infrastructure convergence work over the last years?
So my point on this one is, the fact that we have all the technologies lined up, all the bits and pieces exist, all the Lego bricks. Sorry for using a trademark name here, but everyone understands that all the Lego bricks are out there. Assembling them to build a solution that's fit for your needs is what's hard. That's the complex part. right? Because you are addressing solution or building solutions that need to address the OT priority at the same time they're addressing the IT ones, like Ryan was saying. And building that is hard because there's not many people out there who understand both sides and are able to assemble these bits and pieces. Some have tried to create generic platforms like the IoT platforms that were hosted in the cloud and able to remotely manage all your assets and traverse your network layers of security on your OT infrastructure. And we've tried that. I spent many years at Microsoft trying to put together something like that. All these big companies that try to put together these IoT platforms, whether decided to go vertical, providing a solution for a specific industry with a specific scenario in mind, and do it well so that you would address this problem of OT folks or people on the field not understanding IT. They don't need to because that solution comes all integrated. You want to do asset monitoring or tracking today or fleet management, you have turnkey solutions, SaaS-based, and you don't have to understand anything. You put the tracker, put it on your whatever, you log in online and someone gave you credentials and that's it, right? But there's no such thing as a generic IoT platform that works for everyone. And so the other category, besides the ones going verticals, are the ones stepping out of the last mile and saying, hey, I'm going to bring as much of my part, which usually is the cloud part and IT technologies, I'm going to bring all of that as close as possible to where the data is produced, because what's interesting to most people is the data. That's the goal. That's where you're going to extract insights from. And that's what you need. But you need to go collect it and eventually start managing, transforming, unifying the data as close as possible to where it's produced. And so that's the second camp that I'm seeing out there, and that will certainly help make that integration work, because you come to a point where you have an infrastructure that is an IT one managed by IT people that offer tools to OT world that allows them to deal with the OT infrastructure, OT data, and so on. And they're no longer in conflict. They are actually collaborating. But you still need to have the ones around you that will be able to understand where these needs to go, how much of this cloud technology needs to come to the edge, and is it on super heavy edge servers? Is it on a heavy gateway, or do you need to have some compute on some lighter type of edge infrastructure and devices? And there's no one solution that fits all, and so you need to understand the problem and you need to create an architecture that is adapted and that will work there. And once again, you need specialists for that. That's one of the reasons Ryan and I are very optimistic about what's going on at Things Zero, is because we assemble a group of people who are coming from the different worlds and that can talk to each other and communicate and help customers build these solutions that are customized to their needs, and then also educate them on being autonomous on managing this solution. And having their own infrastructure and IT team dealing with security and all of that, and having their own operators being able to operate these infrastructures themselves. So that's really my take on this one.
Yeah, no, I think all of you nailed it. I mean, it's we're seeing some really interesting players out there, and I think some of the previously IT centric guys, look at the three hyperscalers, Google, Microsoft, AWS. I mean, one of the greatest things that they've done over the past little while is, only trying to do kind of what they feel is good with sort of the cloud and kind of getting down a little bit further, but then opening up their systems to a lot of different tools to come in. So we see the HiBytes integration into AWS. We see Litmus and Site Machine integrating into Azure. I mean, these are the guys that specialize in that certain area. And the hyperscalers have kind of realized, okay, we do really well up top, but when we get down a little bit further, that's kind of where we end up failing a little bit. Let's bring in these specialized tools. I think the other big thing has been, the rise of edge PCs. We see Dell starting to produce industrially hardened PCs, putting them out into the field. And that really creates this nice little split between the IT and the OT side of things, where, the OT guys can run everything into the edge PCs. The IT guys can then take that information out, make sure it's secure and everything else like that. And, like Olivier said, hey, this is, if you look at the team we've got, I mean, we've got everybody from, myself that's been around the manufacturing floor to Olivier on the IoT side, data guys, everybody. I mean, it's a huge, swath of different people that need to come together to make this work. I think that's a big thing going forward for sure.
Now, you guys work also on concepts like zero trust and bringing them into OT. So my first question is, what's wrong with a big fat firewall keeping the world separate? I mean, it's much easier. You stay on your side, I stay on my side, and we'll just negotiate when we need to open a port and avoid all that complication of people of data talking to people of production. I mean, it's already hard enough as it is.
Yeah, you go ahead.
Yeah,
You want to
sure.
have this one?
Yeah, I'll take first crack, and then you can correct me on this one. But yeah, no, I think the whole idea behind the firewalls are great. We always see looking at the ISA 95 stack. You always started back in 1995 when it was developed. You had levels 0 through 4, and that was it. And
It's
all
been
of a sudden,
working for
yeah, it's
30 years.
it's the OT way of doing things. Yeah, if it keeps working, don't even blow on it just in case that causes it to fail. But you had this stack on here, and people started putting in like level 3.5. That was the firewall between the manufacturing operations and the business systems. You had level 5 that people kind of tagged in. All this unofficially, of course, but they put it in as the cloud. And that firewalls are great, for that sort of a stack. But there's two big issues. Hey, once you get past the firewall, you get into the room, you've got full access if it's not zero trust. The other side of things is the changing architecture. So now we move away from the ISA 95 stack where you could only go up and down one step at a time. You're into UNS, you're into Data Hub, whatever you want to call it, however you want to put it. But now you're into this area where you need to have data moving around the organization a lot more flexibly, like connecting a sensor directly to an ERP system. That ISA 95 doesn't really allow that. They're starting to. It's taking a little while. It's like pulling teeth to change stuff.
Ryan, what are you
It's
saying?
blasphemous. I know. It just
I need to change protocol every layer, and I need
Yeah.
middleware upon middleware before I get to the ERP.
Exactly. Yeah, and then you need so many different tools on there. But I think we're starting to see this change and getting away from sort of hardening with a firewall and into more of a zero trust architecture. I mean, I think that's got to be the way it goes to make things a lot more flexible.
Back to my previous point about the fact that you need to have people helping you implement a solution that fits your needs. I think the security aspect of a solution is definitely something that is there's no one rule. Zero trust might be the one rule. The only common denominator is that you have to be careful with everything. But there's no rule that says everything needs to be connected. There's no rule that says you need to switch everything from a non-TCP protocol to a TCP protocol. And there's no rule that says like everything needs to be logged in and whatever, right? And so it really will depend. And you need to work with what you have, which is existing assets and infrastructure that's been here for a few years and will be here for a few decades moving forward. And that would cost more to update and modify than to just operate with the risk of failures or risk of intrusions and data being stolen or equipment being hijacked and so it's all a matter of understanding what kind of needs you have when it comes to actual connectivity. Do you really need to connect everything? That's one of the first questions that usually ask customers who are coming, don't know IoT, that just like, well, we need to do IoT. Like, do you need to connect everything? Do you need to have, maybe not. Maybe what you need is, to not touch your existing assets and add a little non-intrusive sensor that will do the work that, maybe you could have done by recoding your PLC and whatnot, right? And so maybe what you're looking for is not, transforming everything. Maybe you are just looking for an additional tiny device that is not intrusive and that will do its work and it will be modern and all greenfield, all good, right? And so it's something that, if you do these kind of things in certain cases, you don't even need to consider, hey, what do I need to do to secure that, because you will get it by default, in whatever new modern IoT platform you're using for adding that sensor. So that's just an example of a use case of, zero trust is something that might be the only common denominator when it comes to security. And yes, you need to be careful, but, do you need to connect everything? That's the first question you need to ask yourself, in my opinion.
Absolutely. And it is a bit of a paradigm shift. Because and this also maybe comes down a bit to greenfield versus brownfield, or so. Is I can imagine that. Well, I've seen it myself. So when you are in a brownfield installation and you adhere to the good old Purdue model, and jokes aside, it's it's everywhere around us, but that's a different starting point than when you're starting from a greenfield plant, where you go like, oh, we have this nice idea, we're gonna build a new production line for such and such. So where, if we talk about IoT, but more specifically about securing IoT, what difference do you guys see between brownfield versus greenfield? What are, I would say, the right approaches? Is it a similar approach? Is there one approach? Are there different approaches?
Yeah, I can take a first take at this one. There is no one approach. Once again, I think that's going to be my motto for today. There's no one approach. That said, what I would recommend is to consider starting small. Start with your business case, what you're really trying to achieve. Start with something simple. Could be that eventually you have a set of equipments that are from different manufacturers and that you want to monitor in a unified way that everything is up and running and at what pace it's producing, right? And this is a very practical example that we're actually, without naming anyone, working on at Thing Zero. And here, instead of trying to go super wild, was like, wait, we have all these PLCs, and they're gonna give us all these data points from all these assets and so on. And then you're wondering, so once, let's assume I'm able to get all that data and do all my security work of making sure everything comes encrypted and I don't open too many ports and I know exactly what's going on, which is a lot of work. But what will I do with all that data? What kind of information am I going to extract? How's it going to enhance my production? How's it going to enhance whatever, right? Is it opening up for a new business model?
Yeah.
And you need to ask yourself these questions because, if you take it from that perspective, you're not starting with, but dropping all these Lego blocks here and saying, "Hey, now we have a problem with security." You're really in the opposite, saying, "Hey, I'm going to start with that data point. How do I get this from these like 2 machines in that one factory, and then eventually from 2 factories, and then you start asking yourself the questions as they come, which is, first on that one factory, maybe I can do everything on site. I don't need to be connected to a cloud, right? And then I need 2 factories. Okay, so now I need to get the data from these 2 factories into a central point, right? Is it going to be private cloud? Is it going to be public cloud? And the security questions are piling up on top of this very practical, simple use cases. And instead of having the very complex problem from the get-go, you build up from there. And I think this is the one best approach, keeping in mind the long-term goal, which might be to have a fantastic digital twin of all your factories and all the assets that give everyone information about everything, and you automate everything like we used to say everyone when I was at Microsoft, which is, hey, we're going to solve all the digital transformation problem, and you're going to have this like factories, digital twins, technology. From the technology perspective, yes, it exists. All the tools are there. You can do it. It's possible. You can build that digital twin that has a 3D representation that you monitor using your HoloLens, and you interact with all these temperature sensors, whatever, using all virtual reality. And then you can have that information flow into your business automation and reporting to the CEO, and then triggering the maintenance using AI and whatever. You can do all of that. It's not the question. The big question is, do you need it? Because it's going to take some time, a lot of money, a lot of people to implement all of that. It's not going to happen overnight. So do you need it? Is it
many
really
points on our buzzword bingo.
Yeah. Ding, 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 ding. So that's, to me, the best approach to securing your IoT infrastructure and solution is to start with very simple approach, very simple business and use cases. Look at the ROI. Don't go further if you think the ROI is not there. Don't like Ryan said, don't blow on it.
Yeah, and that's, I mean, it's interesting dealing with some of the, you get the guys on the OT side of things that sit there tinkering with, things day in and day out. And now it's the question of like, oh, hey, we can do this. We can connect all this stuff up. Okay, the next question is like, should we do this? Like, do you need all of this information? To Olivier's point, I mean, like, should you do this rather than can you do this? Looking at the different business cases, Olivier mentioned, one item we're working on right now. And, we're starting small in there. It's going to be just two simple parameters we're getting out of here. But it all started with the business case. Okay, why are we going to put this in? When you get stuff being driven from the top down, they start to look at problems like, okay, we need to control our capital costs. If we can avoid, putting in a new machine, that's going to save us millions of dollars over the next couple of years. You bump that out, it's you get a whole bunch of different costs, opportunity costs, and all that other fun stuff. Like we can throw the money at something else if we need to. But okay, how do we figure out what areas we need to actually invest in, and where can we defer investment a little bit longer? Everybody has a love-hate relationship with OEE, depending on who you are, and I'm sure that crosses off another one on the bingo card. But it's a good way to say, okay, how much are we actually using this piece of equipment? Is it being used as much as it can? Is it now become a bottleneck within the process? Or, is this a critical piece of equipment, but we're only using it like 25% of the time? Like, can we adjust our processes to take better advantage of this equipment? And even just looking at like on-off data and, throughput, that's a very easy way to identify whether that piece of kit really needs to be, you need to expand upon it, duplicate it, anything like that. It helps solve the business cases. And the nice thing is, if you're solving the business cases first, then the guys that are controlling the budget, I mean, they'll start to see returns on investment. They'll start to see money coming back in off this. They start to gain some confidence that, when you suggest that crazy IoT application, they're going to be like, okay, the last little baby steps we've taken really worked out well. Hey, these next ones will too. From the cybersecurity standpoint, I mean, if we look at like a big brownfield application, paper machines, if any of you guys walked around a paper mill, I mean, they're the length of I'll say football, and that could mean something depending on which side of the Atlantic you're on, but they're about the same length, right? So something the length of a football, big anyways, yeah, but 100-odd yards / meters. But they're big machines, they get put in, they stay there for decades. They get improved upon a little bit here and there, but other than that, they stay running. Are you going to rip and replace the PLCs and SCADA systems that are running it? No, like you're not going to do that. But, as Olivier was mentioning, start small. Hey, AWS had those great little, and I think they actually discontinued them, which was a shame, but they had those great little like vibration and temperature sensors you could just toss on a bunch of things. And that gives you a bunch of information without having to do all this extra stuff, trying to either rip and replace a big system or trying to implement it in a way that might be opening you up because you're trying to fit old technology into new processes.
Yeah. And one thing to add is it's not because you start small that you start quick and dirty. You actually need to start small, but correctly, do things right, and so don't open everything up. Don't, go for the big hammer to just, put something down there. It's something that is, I'm seeing often and often, which is, the extremes, whether you go full blown with an entire IoT platform and everything in there, the shebang that you're never going to use and you don't even know it's there. It's like using Word to write a little letter. And so you don't need that. You can use Notepad or whatever simple text editor there. And so it's something that, and the opposite is like doing quick and dirty. Yes, you can prototype a very interesting solution with a Raspberry Pi and open everything up and use whatever, open source technologies there on top of that embedded Linux OS. And then, SSH and with the password and all the bad practice, but that will get you to a point where things are kind of working. And then, you have the problems with security, with resilience, with scalability. So it's not because you start small or should start small that you should start quick and dirty. You can start small, but correctly, with, once again, the long-term or mid-term and long-term in mind and where you're going to go. Like data unification is a good example of that. How are you going to start, shaping your data in formats that will work when you have more than 2 data points and you have hundreds. And instead of having to redesign everything when you get to that point, you design things from the get-go with 2 data points, with something that might be a little bit more, over engineered than what you could do, because you will think about UNS, you will think about some form of digital twin, but you will be resilient, and you will be, you will be able to scale afterwards without too much effort, which is what you're looking for. Same thing for security. If you start with good practices from the get-go, you will be less in trouble, and it will be not as hard to secure the at-scale solution that you want to have.
Mm-hmm.
Yeah.
And one term we've not used, but I think it's not just marketing, which is risk management. What kind of risk you want to take? Because when you're looking at the technology and at what pace it evolves, what are the bets you're going to take? I mean, for your future infrastructure and architecture and so on, right? You cannot leave on the past all the time. Yes, you will address brownfield and still have to deal with things that are robust and do work, right? ISO 95 has been here for a long time for a good reason. And so it's not about just like dumping all of that, but it's not either about adopting what's not even like what we like to say GA, right? Things that are in preview, that are in, just being talked about. Yeah. So it's great because it has a big, nice promise. Like UNS is one of these things where nice promise, it's community driven, industry driven, and it's a good concept and so on. Do you want to put all your eggs in that one basket? Do you want to bet your entire business on the fact that this technology is the one that's going to stick, and that there's not going to be another one that will become the standard that everyone will have to comply with or adopt? So you also need to be careful and measure the risk you're taking. And risk is not just about security. Risk is about the choices you make when it comes to adopting technology to digitally transform. And that's something that you need to have, once again, support from people who understand both that technology and your domain sufficiently enough so that it can guide you, that they have the insights, that they have the understanding. Sometimes they have the guts as well. Say, hey, that thing, I wouldn't go there for now. I would wait a little bit more. And sometimes you should try and afford to wait and see what's going on, right? Because some of these very fancy, cool technologies, you don't know. Like, we're talking about security. We didn't talk about, post-quantum. Once we have quantum computers out there, they're going to break RSA or elliptical curves and something like that, where we say, hey, this is very secure, and then suddenly, not so much, right? And so, is it or is it not? Like, should we bet on adopting a new encryption model today is going to be super expensive, you need to change your hardware and so on, or maybe not? I don't know. We don't know yet, but you need to think about it.
It's a difficult, and there is always something. Let's suppose that we were able to convince the management team to buy in this, I would say, initial investment. Yeah, there is no ROI yet, but we'll start small. Let's suppose that the right platform has been selected. Next problem: data management. Because anyways, I'll let you. I'll let you guys explain. But what I find very interesting here is, we're starting somewhere, and then the first thing is, okay, should we now start talking or thinking about how are we going to unify, or how are we going to structure our data, or going to adapt ISO 95 or something similar, or should we just go with the flow? Any thoughts?
Go ahead, Ryan. I'm sure you have thoughts on this one.
I was going to say, it's, if they're throwing money at me, I'm going to take a nice vacation. It's going to be great.
Fair enough.
It's perfect. Hey, data management is an issue from the ground up. Even we're starting out small. I mean, like, the first thing is, again, going back to, reliability, repeatability, contextualization, all that fun stuff. It's always an issue. And I think for many companies, going back and even just making sure that the data they're getting is the right stuff that's coming out. I've been in many applications where they thought they were getting, certain numbers out, and it turns out that even low down they weren't. But I mean, there's so many different things that can come out of that, and so many different ways of pulling data out. It's a big issue, and we see, I think, HiByte was formed on the whole premise of like contextualization and model development. That's how big of a problem it is that you can have a really nice, successful company like HiByte being spun out of something like that. But yeah, it's something that really needs to be worked on. It's a problem. It's something that I think if you're going to do that, it needs to be addressed. If management's throwing a ton of money at you for all this new infrastructure, the next big thing is like, okay, how are we going to manage it? What models are we going to put into there? And how are we going to standardize on everything? Even we were kicking one conversation around ISA about a week or two ago. Error codes. Error codes might seem like the stupidest thing out there, but if you're trying to figure out what's broken and why, how do you develop standardized error codes that are going to be replicated across the enterprise? There's no standard out there. From what I hear, IT has one on the HTTP side of things, but there's nothing on the OT side to say like, hey, why did this machine break down? Was it just because the operator needed to go in, or there was like an oil leak or something like that? And even worse, I've seen applications where they've put these error codes in, they hand the tech the tablet, and they say, okay, every time the machine stops, I want you to press the button that corresponds to Y. And they started looking at it, they're like, oh man, this one reason keeps coming up all the time. And they realized that it was only because that reason was in the top left-hand corner of the screen, and they kept pressing that one over and over and over again just to get the machine up and running. So it's standardizing, and then it's also trying to convince the guys on the shop floor, hey, you need to put in an extra second or two just to give us this information so we can have the data to make better decisions further down the line.
Yeah, definitely. And one thing that I noticed is the fact that we already have a lot of data. Like we're talking about IoT and modernizing equipment and so on, but diagnostics generated by machines these days, they exist, right? We have historians of huge amount of data that have never been analyzed or looked at because there's too much of it. It's not unified as well. So across two different, branded of the same device, you might have the same type of data. So it's super hard to correlate that and to understand what's going on there. But I think we have lots of tools that allow us to first eventually look at these historians. We can also leverage generative AI, LLMs to start deciphering all of that, making sense of it. So UNS is great because it's about formatting and formalizing data from the get-go when it's produced. But we need to think also about, what do we do with this huge amount of raw data? It's existing knowledge that is out there on existing brownfield machines that no one does anything with. One thing I've learned working recently, especially on edge AI rather than just pure AI, so AI running in the cloud versus AI running at the edge, where you need to optimize your models for running at the edge, is that if you have bad data, you're going to have bad models. So going back into these huge amount of data that has been produced, that exists already, and being able to clean that up, understand that, sometimes you don't even need to implement any sophisticated IoT solution, especially to fix this existing machine infrastructure, whatever. And you might realize by analyzing that huge amount of data that, I had this problem for a long time. Didn't realize that it was due to this or that. And now I can improve my production by 20% by doing this little tiny change, right? And you could not do that because you don't have the tools to analyze that huge amount of data. So I think my point is, because I'm going on tangents, my point is you might not need more data. You might not need a lot more data. Maybe what you need is a couple of additional data points that will address, or that would help you address the problems you have at hand that have an ROI, right? So you're really focusing on the ROI and the fact that you have use cases in mind, and you will deal with the data based on that. What kind of data? How do I clean it up, analyze it, unify it, create new data, store it somewhere, right? Storage is not free, by the way, not in the cloud, not on premise. It has a cost.
No.
Exactly. And then security on top of that, once again. So.
All right, we have touched on IoT topics in the podcast and on the blog. I think we've written about data quality, we've written about data platforms. We had the interviews with HiByte, Litmus, and the other ones. So I think this is a great addition to our as a 31st episode. But still,
That's a good one.
Thank you so much. Another great episode in the books. Olivier, Ryan, thank you both for joining us.
Hey, thanks for having us.
So you can find both gentlemen, of course, on LinkedIn, on their websites from I would say their thingzero.com. I guess it's .com. Yeah, we'll add a link to the show notes. As I said, Olivier has a very active YouTube channel on IoT. Just look for the IoT show, and I'll also put a link in the show notes. To our listeners, thank you again for tuning in. Make sure to subscribe and via itotinsider.com. And until we meet again, bye-bye.